properties that you likely have seen before. Okay, but I'll jump around. I'll do maybe one or two examples of each type, and then I'll give you time to practice to try to refresh your memory. Okay, so just basic exponent rules. Sorry. So like 2m squared times 2m cubed. Okay, so this is not distributing. You don't like do this because these are all glued together. They're not separated by a plus or minus. So you just multiply each like part. So you multiply the coefficients together, right? 2 times 2 is 4. And then you also multiply the m's together. Yeah. So if you ever forget the rule, like, oh, do I add the exponents or do I multiply them? My advice would be to write it out without an exponent. Okay, so for example, m squared we know means 2m's multiplied together, and m to the third power means 3m's multiplied together. So when you multiply m squared times m to the third, you get 1, 2, 3, 4, 5m's all together. Yeah, that's the shortcut. But yeah, I was just showing a strategy if you forget the rule. If you forget the shortcut, then you can sort of figure it out by expanding it. Okay, but yeah, some of you mentioned the shortcut or the pattern is that when you multiply two terms with the same base, you add their exponents. Okay, so that might help us with the next one, right? So 4r to the negative third power times 2r squared. So again, you would multiply the coefficients together first. 4 times 2 is 8. And then now for the r terms. Okay, so there's different ways you can approach this problem, but one way is to use that pattern. When you multiply, again, two terms, you keep the base and you add the exponents. Yeah, so good question. I'll answer that in just a second. But yeah, so first, you cannot leave your answer right here. In general, in order for your answer to be considered simplified, you can only have positive exponents. You cannot have a negative exponent.
So it's like if the negative ones the top, move it to essentially the denominator.
Right.
Negatives in the denominator instead of the numerator.
Correct. So in this case, the exponent only affects the nearest thing. So the -1 is only attached to the r. It's not affecting the 8. Yeah. Yeah, so it's not this. It's just this.
8 over r, okay.
Yeah. The 8 will stay where it is. But then, yeah, the r to the power of -1 moves into the denominator. And that's how you turn a negative exponent positive. All right, so yeah, in general, if you have like a to the power of negative b, that would become 1 over a to the power of positive b. All right, so that's how you can get rid of a negative exponent by moving it to the other part of the fraction. Okay, but yeah, if the negative exponent were already in the denominator, so let's pretend we had 3 over x to the power of, oh, let's do something, let's do like 3 over 4 to the power, sorry, 3 over 4x to the power of -2. So the 3 will stay where it is, the 4 will stay where it is, but the x will move to the other part of the fraction and the exponent will become positive. Yeah, this is just a separate problem. It's not one of the ones that was already on your paper. Okay. And I think that's all you need for this first section. So yeah, go and take a minute and try to do the other 4 problems in part 1. If you feel like you've gotten them, you're welcome to continue. Again, most of these problems you've likely seen before. All right, so letter C, you have 2 times 4 is 8, and then k to the 4th times k to the 1st, so 4 plus 1 would be 5. Over here, 3 times 2 is 6. Now, y squared has no other y's to combine with, so that will be unaffected, and the x also has no like letters to combine with. But we do want to put the letters in alphabetical order within each term. Okay, so 6xy squared would be the proper way to write it. If you wrote 6y squared x, again, that's understandable, but we want to get used to putting the letters in alphabetical order within each term. Okay, so over here, you've got 3 times 4 is 12, then a to the power of 3 plus -4, and b to the power of 2 plus -3. Okay, so a to the power of -1 and b to the power of -1. Okay, so the 12 is not to an exponent. The 12 will stay where it is, but the a will move into the denominator, and the b will move into the denominator. Okay, again, you don't need to write the exponents of 1. It's assumed to be that if there's nothing else. Okay, and there actually was one other little wrinkle to this problem that I didn't mention, but let's just start by doing 2 times 2 is 4. Then you have x to the power of 3 plus -1. And then y to the power of -3 plus +3. Okay, so y to the power of 0. This is one of those kind of tricky things to remember. Yeah. So, yeah, any other number, I don't know. Yeah, I'll just use x. Right, so whether it's 5 to the power of 0, 1 to the power of 0, -6 to the power of 0, any other number. Yeah, besides 0 itself. Yeah, 0 to the power of 0 is indeterminate. Yeah, but in this case, okay, so y to the power of 0 is 1, and anything times 1 stays the same. Okay, so yeah, it's very easy to mess up and say, oh, anything to the power of 0 is 0, which seems like it would make logical sense. But let me give you a quick example that maybe, yeah, yeah, yeah. So, for example, let's say you had 2 to the power of 3 over 2 to the power of 3. If you simplify them separately, 2 to the third power is 8, 2 to the third power is 8. So we know the right answer is 1. Now, if we, oh, I should have done it the other way. Okay, it's fine. So the pattern we're going to see a little bit later, right, is when you divide two terms, you subtract their exponents. So that same problem turns into 2 to the power 0, right? So 2 to the power of 0 must equal 1 then. Okay. Let's go and move on to part 2. So yeah, here's what we just saw, right? But what happens when you have an exponent to another exponent? You multiply the exponents. Okay, so for this first problem, x to the power of 2 all to the power of 0, you would multiply the exponents to get the new exponent. And then using that new pattern, we can assume x is not 0. So x to the power of 0 will equal 1. Okay, now for letter B, now you've got 4r to the 0th all to the power 4. Okay, so another thing you should know is that when you have multiple things inside of parentheses all affected by an exponent, both parts get affected by the exponent. Okay, so in this case, the outer 4 affects both the inner 4 and the r to the power of 0. Okay, so you have 4 to the 4th power, and then times r to the power of 0 times 4.
So it'll be 0.
Right, so that part will become 0.
The 0 does still make it 1.
Okay, so yeah, r to the 0th is 1. But now for our final answer, if you just have a regular number to an exponent, please do the math and tell me the final number rather than leaving it with an exponent. Okay, so 4 to the power 4. 4 times 4 is 16, times 4 is 64, times the last 4 is 256. Okay, so 256 times 1 would be 256 overall. Okay, so yeah, the two things you need for this section, exponent to an exponent, you multiply the exponents. And when there are multiple things in a parentheses, the outer exponent affects all of them. Okay, so yeah, go ahead and try the rest of part 2, please. That section. Letter C, the outer exponent affects both the 3 and the k to the 4th. So 3 to the 4th, 3, 9, 27, 81. And then here, exponent to an exponent, you multiply them. So 81k to the 16th. Over here, again, outer exponent affects both parts. Okay, so 2 to the power of -1 becomes 1 over 2 to the first power, or just 1/2. And then you have b to the power of -4. So yeah, this will move into the denominator also. Exactly. Okay, letter E. Again, exponent applies to both parts. So the x to the 4th can stay, but the y to the -2nd power needs to move into the denominator in order to become a positive exponent. Okay, and then over here, all 3 parts get affected by the negative. So 2 to the -1st, x to the 4 times -1, y to the -3 times -1. Sorry, messed up that x. Okay, so the x to the -4th, that means the x will move down to the denominator, but the y is positive, so the y gets to stay where it is. So I guess we don't really need the coefficient of 1 in front anymore. Okay. So questions on anything so far? Okay, so now dividing. So I already did a little example of this, but okay, let's just do letter B. Okay, I'll do both. This one's fast. So the coefficients you would divide like normal. 3 divided by 3 would be 1. So I'll just temporarily write that. Okay, then when you when you divide two terms, you subtract their exponents. Yeah, so order does matter. It's numerator exponent minus denominator exponent. Okay, so yeah, 1 n to the first power is just n. Okay, so now just so you know, when you do this subtraction though, the n starts in the numerator, and then it would only move to the denominator if negative. But what happens a lot is people put it in the denominator, then they flip it back up to the numerator. Okay, so let me show you letter B. Okay, so the 2 and the 3 don't reduce, so I'm just going to keep both the 2 and the 3 where they are. Okay, so now when I look at the x terms, again, we start in the numerator, and we do numerator exponent minus denominator exponent. Same thing for the y's. Even though there's some negatives involved, you still start in the numerator. So -4 minus -3. Watch your many negative signs. Okay, and then again here, when you first do the subtraction, you start in the numerator. So -3 minus +4. Okay, so simplifying, 4 minus 2 is 2. -4 minus -3, you can add the opposite. So -4 plus 3 becomes -1. And then z, -3 minus 4. Again, instead of subtracting, you can add the opposite. So -3 plus -4 becomes -7. Okay, so the 2 can stay where it is. The 2 doesn't have a negative exponent. The x squared can stay where it is. The 3 can stay where it is. But the y to the negative first up top will move down here and become technically y to the positive first. And the z to the -7th would move down here and become z to the +7th. Okay, so yeah, again, your answer can only have positive exponents. So yeah, go and try the rest of part 3, please. 3 now. So for letter C, 4 divided by 4 is going to be 1, right? And then actually the x to the 0th is also 1. Some of you may have done 0 minus 1 to get x to the negative first. You can, or if you recognize that x to the 0th is just going to be 1, then this x has nothing affecting it.
Yes.
Yeah, so either way, you'll end up with an x in the denominator. The y to the -2nd power up in the numerator, that moves down and becomes y to the +2nd. And the z to the 3rd is already positive. There's no z's down here to affect it, so it stays up in the numerator. Okay, so yeah, final answer, z cubed over xy squared. Letter D. The 2 and the 3 that are your coefficients, they don't affect each other, so they stay. There's no h's to affect the numerator, so you leave the h cubed. The j's, you've got -3 on the numerator, -1 in the denominator. And the k's, you've got 4 up top, minus invisible 1 in the denominator. -3 minus another 1 is now -4. Okay, so the j will move down to the denominator and become an exponent of +4. Okay, again, there's multiple ways to do these problems. Like some of you, instead of subtracting these, you may have moved this j down and then combined it with that j. Yeah, there's many different orders you could get the right answer. Okay, here, 4 and the 3 have no common factors besides 1. We'll subtract the m exponents, the n exponents, the p exponents. Okay, so the p has a negative exponent, so that'll move down to the denominator. Okay, and then over here, let's see, the 3 has nothing to affect it. X, 3 minus -4. For the y's, again, you could do -1 minus 0. But y to the 0th power we know is 1, right? So subtracting 0 doesn't change the value anyways. Okay, so right now there's currently no denominator, right? But I'll just put like a temporary 1 there. 3 minus -4 is 7. Okay, and then now the y and the z both move into the denominator. Okay. Okay. Part 4, actually, I don't think really adds anything new that we haven't seen before. Yeah, it's just a combination of some of the earlier steps. So for example, part A, there's a couple different ways you could approach it, right? I'll show you 2 ways. One way is you could first apply the exponent. Okay, so exponent to an exponent you multiply. Then when you multiply two terms with the same base, you add their exponents. Okay, and now that you have a negative exponent, it needs to move to the denominator. Okay, so 1 over x to the 20th. But just to show you that there's multiple ways to do these problems, another way you could have approached it is first you could have combined up the inside. You could have left the exponent 4 and then added the -2 plus -3 on the inside. Okay, and then now you have -5 times 4, which again gets you to -20 as an exponent. Yeah. So again, you don't need to do it multiple ways. I just wanted to show you that there are multiple ways. Okay, so yeah, again, part 4 doesn't contain anything brand new. It's just combinations of the first 3 steps. Okay, so yeah, go ahead and try part 4, please. So letter B of this section, the 4 times -3 would become a new exponent of -12. The 2 has no other coefficient to affect it, so the 2 stays. But now when you multiply these x terms, you add their exponents, excuse me. And since we have a negative exponent, we need to move that into the denominator. So the 2 does not move with it. The 2 is not affected, only the x. Over here, you have 2 squared v squared. 2 squared is 4. Okay, so 2 times 4 is 8. And then v squared times another v squared. You would add those exponents to get v to the 4th. Okay, so over here you have 3 k terms. You can combine these 2 first and then combine it with that after, or you can combine these first and do that after. It doesn't really make a difference. I'll choose to combine the top 2 first. Okay, so I'm leaving the 2 alone. I'm leaving the k to the -3rd alone, but we'll combine these together. Okay, so since they're multiplying each other, you add their exponents. And now you can combine these 2 together. Those are getting divided, so you would subtract their exponents. But 5 minus -3, you add the opposite, so okay, over here. Again, there's different ways you can do this. I might combine up the denominator first, because when you do -1 plus 1, that becomes x to the power of 0, right? Which becomes 1. Okay, so now the -4 affects both the 2 and the x. Okay, so they're both going to move into the denominator. Now there's nothing left in the numerator. Both of these move down. So we need to put a 1 up there. Okay, and then remember, don't leave a number with an exponent. 2 to the power of 4, 2 times 2 times 2 times 2 would be 16. Okay, and then last one over here. Again, you can do this in various orders. I'll go ahead and just do the exponent to an exponent first. So -3 times 4 gets us to -12. Sorry. Again, you can either combine these first, or you can combine these, or you can try to combine all 3 at the same time. I'll just combine the top 2 first. Okay, so now we have x to the -8th over 2x to the -3rd. So subtract. -8 minus -3, or -8 plus 3, that would become -5. Okay, so that'll move down to the denominator, and there's nothing left in the numerator, so you need to put a 1. Yeah, 1 over 2x to the 5th. All right. So now, next, remember this unit 3 is radical functions. So we need to also go over some radical properties. Okay, so first, converting from fractional exponents into radicals. So the pattern is, if you have some base a to the fractional exponent b over c, the denominator becomes the index of the radical, and the numerator of the fractional exponent is the exponent on the inside. Okay, so over here, you could first rewrite this as the cube root of 2 to the 5th power. But we wouldn't stop here. Radicals are not simplified until you've taken everything you can from the inside to the front. Okay, so here it may help to rewrite the 2 to the 5th as 2 to the 3rd times 2 squared, right? You can split up the 5 2's into a group of 3 and a group of 2, because whenever your exponent matches the index, you get to take the base out front. Okay, so the 2 gets to move out front. And then again, on the inside, you can't move the 2 squared out. The exponent is not big enough to match the index, but we do want to return this into a regular number. Yeah, 2 cube root of 4 is how we would say this. Okay, jumping down to letter C, right? So both the 10 and the n would be affected by this exponent. Okay, but I'm going to group them together. So the denominator of 2 means it's a square root, right? We know we don't really need to write the 2. But not just the n, but the 10n in parentheses is getting affected by the exponent of 3. Okay, so now I will go ahead and apply the 3 to both the 10 and the n. Okay, so now like before, because the index is the denominator of 2, my goal is to form exponents of 2 on the inside. So yeah, so because we have 3 10s to work with, we can use 2 of them up. And same thing with the n's. Out of the 3 n's, we can use 2. And then you have 1 left over 10 and 1 left over n. Again, you have 3 to start, so I group them to a 2 and a 1. Okay, so this 10 gets to move out. This n gets to move out. But then inside, we still have a 10 and an n. Okay, this one is very similar. I'll just go and do this real fast. Again, you don't really need to write the 2, but because the exponent is 3 and you're trying to match the index of 2, you would again split up the 6 cubed into a 6 squared times the leftover 6. So now that you have matching exponents, you can take this 6 out. Okay, so this last one is significantly different than the other 3. So here we have a negative exponent. Okay, so like always, that could be turned into a fraction in order to make the exponent positive. Okay, so now what do we do from here? So the, again, denominator is the index. And then the numerator is the new exponent. Okay, but just like the previous problems, right? Whenever the inside exponent is bigger than the index, that means you have more than enough. So you want to split up the 5 to make a group of 4. Okay, so instead of having, so right now we have 5x to the 5th power, which we know means 5x times 5x times 5x times 5x times 5x. Okay, so we're going to group 4 of them together into a parentheses 5x to the 4th. And then we still have one left over 5x at the end. Okay, so the reason we do that is now this parentheses 5x gets to move outside because it has the correct exponent. Okay, you still have a leftover 5x here. Okay, so now we cannot stop here though, even though we now have it as a radical and we've taken as much as we can from the inside out. The other rule is that you do not leave radicals in the denominator of a fraction. Okay, so how can we get rid of this denominator? Well, again, if the exponent were a 4, we would get to move it out. Right now, the exponent is invisible 1. Okay, so to get to 4, we need 3 more 5x's, right? If we could somehow get 3 more 5x's, then we could form another group of 5x to the 4th power. Okay, so where do these come from? We need to multiply them in. Okay, so now always multiply by the same type of radical. Okay, so again, y parentheses 5x cubed, because that's how many you need to form a group of 5x to the 4th, right? You just have 1 currently, so with 3 more, you could get 4 total. Okay, so like always, if you multiply the denominator of a fraction, you need to multiply the numerator. Okay, so in the numerator, right, 1 times anything, the 1 doesn't change it. In the denominator, we already had this outer 5x, but now on the inside, right, the whole point was 5x times 5x cubed will combine to 5x all to the 4th. Okay, so now this 5x gets to move out to join the other 5x. Okay, now in the numerator, we cannot move the 5x out because its exponent is only 3. It doesn't match the 4. Okay, so we'll go ahead and expand it out. All right, the exponent affects both the 5 and the x. Okay, so in the numerator, 5 cubed is 125, x cubed is x cubed. In the denominator, 5x times 5x is 25x squared. Yeah, so that one had a lot of steps. Okay. So any questions on anything up to this point? Yeah.
Why did you get the 3 when you were doing right at the beginning? When you were like, why you-
This one, these 3?
yeah,
Okay, so it's because I looked at the current exponents in here and I needed to figure out what to multiply by to match the index of 4. right? So in like a different problem, if we had something like something over the fifth root of x cubed, right? To get the 3 to match the 5, you would need 2 more. So here you would multiply by x squared because 3 plus 2 is 5, right? Or if you had something like the seventh root of just x, right? To make the 1 match the 7, you would need 6 more. All right, so basically this plus this needs to equal that. So in this problem, the invisible 1 plus the 3 will match the index of 4. Other questions? Okay, moving on then. Okay, so on the back, we are now starting with the radical and trying to rewrite it in exponential form. So,
1/3.
not quite actually. So the index of this square root, the invisible index is actually a 2 because it's a square root. Yeah, so by the way, the 3 can either be inside or outside, meaning, yeah, these are the exact same thing. Yeah, so whether the exponent is inside the radicand or outside, those are equal. Yeah. So yeah, using the same pattern as the previous page, like if you have a to the power of b over c, that's equal to the cth root of a to the power of b, or again, you can write the b on the outside. Okay, so yeah, go and take just 30 seconds and try parts B, C, and D of part 7, please. Okay, so again, you can use this relationship to help you. So yeah, for letter B, the invisible exponent is a 1. Right, so yeah, there's a lot of invisible numbers in math. Sometimes it's a 0, sometimes it's a 1, sometimes it's a 2. Here, the exponent would be invisible 1. Okay, so that will be rewritten as 2 to the power of 1/6. Okay, letter C is very commonly missed. This is not the correct answer. Does anyone see what is wrong about this?
3 to the 4th third and 8 to the 4th third.
Yeah, so both the 3 and the A are affected. So probably the best way to write it is with parentheses around it. Yeah, that because both the 3 and the A are affected by the radical. So they both need to be.
Okay.
Yeah.
Okay. Yeah, which makes sense because without parentheses, it would only affect the A.
Exactly. Okay, and then for this last one, again, both the 3 and the K are affected. So we will again need parentheses. This one's a square root, so the index is invisible too. So this is not exponential form. Exponential form means you have a single base to a single exponent. So to make this exponential form, you would get rid of the fraction by sort of going the opposite of normal. You would make it a negative exponent. Right, again, I know on the front page I told you, oh, don't leave negative exponents in your final answer. But for this section, I specifically said give your answer in exponential form, which means that you have to use the negative exponent. Okay, so parts 8 and 9 are actually pretty much the same. So let me just do part 9, letter B. Okay, so 25 b to the 6th all to the power of -1/2. So here it might be helpful to rewrite -1/2 as the fraction -3/2. Okay, so yeah, when we distribute this out, okay, so 6 times -3/2 becomes -9. Okay, so we can move this all to the denominator to make the exponents positive. Okay, so the b is fine. The b is to a positive exponent now. But what do we do with this? We don't want fractional exponents in the denominator. Well, let's go ahead and rewrite this in radical form. So again, the b is unaffected. I'll just put it in front. It's only the 25 that is to a radical. Okay, so you have two choices. The exponent of 3, you can put it inside or you can put it outside. I would recommend putting it outside because if you put it inside, 25 to the third power is a really big number. But if you put the 3 on the outside, then you first square root the 25, which makes the numbers a lot smaller. Okay, so again, just leave the b to the 9th alone for now. The square root of 25 is regular 5. And now 5 to the, exactly.
5.
Mm-hmm. Okay, so yeah, that's really the last thing you need. Okay, so go ahead and try to do the rest of this page. I think we've introduced all the concepts at this point. Okay, so like 9 to the power of 1/2, that becomes the square root of 9 to the first power. So 9 is 3 squared. Remember, you can do the factor tree. And then the 3 gets to move out, so the radical is empty and it disappears. Okay, so it's just 3. Okay, so same thing with what is this, 1 million to the power of 1/6. The 6 becomes the index. The 1 million is on the inside. Again, technically to the power of 1, but anything to the power of 1 stays the same. And yeah, so 1 million, sorry, that's not right. You could split this up. You don't have to go all the way to prime numbers necessarily, right? So this is 10 times 100,000. 100,000 is 10 times 10,000. 10,000 is 10 times 1,000. 1,000 is 10 times 100. 100 is 10 times 10. Right, so 1 million is equal to 10 to the power of 1, 2, 3, 4, 5, 6.
So 10.
Yeah. So yeah, we can rewrite 1 million as 10 to the 6th power. So now the 10 gets to move out.
The fractional exponents are the same thing as the radicals, kind of.
Exactly, yeah. For letter C, here I would recommend distributing the fractional exponent by multiplying it by the current exponent. So 6 times 1/2 is 3. Okay, and then for letter D, this one has a couple steps. So again, I'm going to start by applying the outer exponent to both parts of the inside. 12 times -1/6 is -2. And then we have 64 to the power of -1/6. Okay, so both of those are negative, so I'll move them both into the denominator. Okay, so the n squared is fine. That exponent is not negative, it's not a fraction, but we can't leave the exponent of 1/6. Okay, so I'm going to rewrite the 64 to the power of 1/6 as the 6th root of 64. Again, technically the 1 would be an exponent, but you don't need to write it. Okay, so what can we do with 64? 64 is 8 times 8. 8 is 2 times 4. 4 is 2 times 2. So 64 is equal to 2 to the 6th power.
1/2m².
Right, so now we can take the 2 out because the exponent of 6 matches the index of 6. So the 2 moves in front, and that makes your answer 1/2n². Yeah. Okay, so I know not everyone got to this bottom section, but let me just do a couple so that you can see different ways you could have approached this. Okay, so like letter C. All right, so you've got 2 and 4. Those can definitely reduce. Now, what do we do with these? Well, the exact same thing we did when they were whole numbers. When you have the same base and you're dividing, you still subtract the exponents, even if they're fractions. Okay, so that would be your starting point. Okay, so now, because you're subtracting fractions, you do need a common denominator. 4 and 3 could both turn into 12. Okay, so negative 21 twelfths minus another 16 twelfths becomes negative 37 twelfths. Okay. We have a negative exponent, so we can make it positive by moving it into the denominator. There's nothing left once the x moves down, so we have to put a 1 there. Sure. Yeah. No, it'll probably take a couple of days to finish grading everything. Mhm. Okay, so
2x to the third times the 12th root x.
okay, so yeah, that's a good idea. So you could basically convert this improper fraction into a mixed number. 12 goes into 37 3 full times, and then you have 1/12 left over. Right? So I know that you learned you learned mixed numbers pretty early, and then we kind of went away from it. We said, oh, we like improper fractions more. But in this case, it might be better to go back to the mixed number, right? Because you have 3 whole x's. Yeah.
Fraction.
And yeah, so you have 3 whole x's and then 1/12 of another one. Okay, so again, hopefully you understand how this turned into this. Again, you have 3 full x to the thirds, or you have a full x to the third, and then the leftover is the x to the 12th. Yeah, so that means we're not done because we can't leave this part.
That one of the things was the 12th root of x.
Yeah. Yep, so yeah, we can rewrite x to the 1/12th power as the 12th root of x. And then now, just sort of similar to what we did earlier, we want to match the index of 12. Right now, it's only an invisible 1, right? So how much more do you need to get from 1 to 12? You need 11 more. Okay, so you would multiply by the 12th root of x to the 11th power. Okay, so again, y11, because 1 plus 11 will match the 12. Okay, and whatever you multiply the denominator by, you have to multiply the numerator by. Okay, so yeah, the whole point is that x to the first times x to the 11th inside the 12th root will be x to the 12th. So now you can take this x out. When you take things out, they multiply what's already there. So 2x cubed times a new x gets bumped up to 2x to the 4th.
to absolute power.
That's the denominator. Okay, and then lastly, I'll do letter E. This one looks really complicated. You got fractions everywhere, you got negatives everywhere. But actually, it's not that bad if you distribute out the 4 first. So now this affects both the numerator and denominator because the whole fraction is within parentheses. So every single part, the exponent gets multiplied by 4. Okay, but that's actually good because that'll cancel out these denominators. 1/2 times 4 is 2. -2 times 4 is 8. I'm not sure why x and y are switched. I'll switch them back. -7/4 times 4 is -7. Okay, so now we can just do 2 minus -7. And over here, 8 minus 4. Okay, so that becomes, yeah. Oh, sorry, this should be -8, my mistake. 1 second, I'm almost done with this problem. Okay, and then we just move the y down to the denominator. Okay, so